was asked in June 2011 CSIR NET. So here Hamiltonian of a particle of unit mass moving on in xy plane is given by this Hamiltonian is equal to this. This is the Hamiltonian given, and so here initial values are given, positions and momentum. So during the motion, the curves traced out by the particle in xy plane and pxpy plane. So we need to find the curves. It may be parabola or circle or hyperbola traced by this motion. So let me show you how to do that. So here you see, as this particle is moving in the plane x and y. So first we will find the relation between x and y, and then we're going to find the relation between px and py. So for that purpose, let me write the given Hamiltonian first. Okay, so here the Hamiltonian is x px minus y into py minus x square by 2 minus y square by 2. So here we are going to use Hamiltonian equation of motion. So we know the Hamiltonian equations of motions. Here you see was given by q dot is equal to del h by del p, and p dot was given by minus del h by del q. So here q represents position, isn't it? P represents momentum. So here positions are in terms of x and y. So here we are going to find first x dot by Hamiltonian equation of motion. It will be given by del h by del px now. So we are taking x components. So now and y dot will be del h by del py. So let's find these two separately. If you find it, x dot represents dx by dt, then if you differentiate this with respect to px, if you differentiate the Hamiltonian with respect to px, then what you will get? Then you will get only x. Only this term consists px, isn't it? So remaining terms will be 0. And from here, if you simplify it, you will get dx by x is equal to dt, and integrating both sides, if you integrate these two on both sides, you will get log x, where base should be considered as e, is equal to t. So it implies x is equal to e to the power t. This is suppose equation number 1. And similarly on the other side, here this is dy by dt again. So here it will be the term consisting py is this only, so remaining terms will be 0. Here we will get minus y. Then if you simplify this, dy by y is equal to minus dt, and integrating this, then we will get log of y base e here minus t. That implies y is equal to e to the power minus t. This is supposed to. Okay, now if you multiply x and y, 1 and 2, equation number 1 and 2, if you multiply equation number 1 and 2, if you multiply these two, then what you will get? Then you will get xy is equal to e to the power positive t into e to the power negative t. So that gives you 1, isn't it? So this is an equation of hyperbola, rectangular hyperbola. Okay, so now let us find this That means we are going to find this is equation of hyperbola, rectangular hyperbola. Let me write it. Sorry. Now let us find p dot x for x component. So then you will get, according to this equation, minus del h by del x. So if you do so, del h by del x, then what you will get? You will get del px by del t on the other side minus px plus c. So here you can see it implies del px by del t plus px is equal to here it should be x, okay, equal to x. Now we have already got that x is equal to e to the power t. Here we have got, so we can put here e to the power t. So instead of x we can put e to the power t. So let me write here e to the power t. This is e to the power t. Now, so this is a differential equation, linear differential equation of this form: dy by dx plus capital Py is equal to q. Here capital P and capital Q represents function of x here. Okay, so function of x here in this case only. Now you see here what we are going to consider. Here you see, in this case, if you compare with this equation, with this one, then what you will get? Then you see, let me show you here. So in this case, instead of x there is t. Okay, so in this case, instead of x there is t. So we know the solution of this form of linear equation is given by y e to the power p dx is equal to integration. So here this sign is integration. Okay, so let me clear this thing. So this solution is given by y e to the power integration p dx is equal to integration q into e to the power integration p dx plus c. So this is the solution of this kind of equation. Now you see, if you compare this equation with this, then what you will go here, we can consider that in this case px as y. Here we can consider px as y. Here you see, instead of y there is px, and instead of x there is t. So if this is y, so if you compare this p with this equation, and if you compare y with this px, then here this value of capital P is 1 here in this case, and q is e to the power t. So that's why solution of this equation must be px e to the power dt, because p is equal to 1 here, capital integration e to the power t. Instead of q we have to consider e to the power t, then e to the power integration again dt, then plus, suppose take c here. Okay, let us say c. So this is the solution. Then if you solve this equation, then what you will get, if you simplify this, then it will imply, so let me scroll up the page, I scroll down the page. So then you will have px e to the power t is equal to e to the power 2t by 2 plus c. Now as we have got p dot x, now let us find p dot y, py dot. So if you find py dot, that's gonna be minus del h by del y. So if you differentiate it, this Hamiltonian, here you see, if you differentiate it with respect to y, then what you will get, let me show you. Then you will get py plus y. Okay, you get this. And again we have got y is equal to e to the power minus t. So here we can write py plus e to the power minus t. So that implies, we know p dot means dp by dt. So here py d, so dpy by dt here is equal to, so what we're going to do here, let's bring this py to this side, then it will be minus py on the other side, e to the power minus t. So again this is also in this form, so that's why its solution will be again py e to the power minus t e to the power minus twice t by 2. So here it was, you can see we had e to the power 2t and e to the power t here, but on this side as we have t e to the power minus t, that's why solution should be replaced by, instead of positive t it will be replaced by negative t only, that's it, plus again a constant c. So let me give this c as c1 and this one as c2. Okay, these two constants be c1 and c2 in both cases, two different cases, so two different constants we have taken. So now you see, let us suppose this is equation number suppose 3 and this is equation number suppose 4. If you multiply 2 and 3, if you multiply 3 and 4, if you multiply equation number 3 and 4, before we're going to multiply, let me do one more thing. So what we are going to do, first let us determine the values of c1 and c2. How to find that? So we have already got this initial case that px 0 comma py 0 is equal to half and minus half. We have already got this, it is given in the question. So here you see, if you check the question, here it is given. Okay, then what will happen, and p of 0 and p of y, py of 0, then we have half and minus half. So I have done a mistake here, and that should be minus half. So if you put these values here, you can see, so this is nothing but 0 is nothing but it is t. Okay, it is t. So in that case what you're gonna have here, so this is instead of t we are going to put 0, and respectively py and p2, px and py will be half and minus half. So if you put these values, then what you will get, let me show you. So equation number 3 implies, if you put here half and here 0, then you will get half here, and on the other side this term will be 1 and plus 1 by 2, not only 1. This denominator term will be 1 only, because here t is 0, then e to the power 0, anything to the power 0 is 1, so we will get 1 by 2. plus c1. So here half half cancels, so we will get c1 is equal to 0. Similarly, we will get equation from equation number 4, we will get c2 is equal to 0. So c1 and c2 is equal to 0. So here this is also 0 and this is also 0 in equation number 3 and 4. So that's why we can consider this part and this part only. So if you multiply putting c1 and c2 0 in 3 and 4, if you multiply equation number 3 and equation number 4, then what you're gonna have, then you are going to have px into py is equal to minus 1 by 4, and that is also equation of rectangular hyperbola. So our correct option will be that both cases we have got rectangular hyperbola here also and here also. So that's why, so what will be the correct option if you check it, then let me enlarge it. So here both hyperbolas, so this option is correct. Now let's move on to next question. So this question was asked in December 2011 CSIR NET. So here the particle of mass m moves inside a ball. If the surface of the ball is given by the equation, the surface is given by this equation, that is z is equal to half a x square plus y square, given by this. So a is a constant here, and Lagrangian, we need to find the Lagrangian of this particle. So what will be the correct answer here? So what we can do here first, let me make it black. Okay, so here you see these options are in cylindrical coordinates. So we know in cylindrical in polar coordinates, x is what, r cos phi, and y is equal to r sin phi. Then here you see r square is equal to x square plus y square. So these are our polar coordinates, isn't it? So then what we can write, this is equal to r square, so that's why z will be equal to 1 by 2 a r square. So we have got x is this one, y is this one, and z is this. So hope you have understood. So z dot, in this case z dot will be a r into r dot. So if you differentiate it with respect to t, then you will get this. Then let us find x dot from this equation. If you find x dot, what you will get? Then if you find x dot, then you will get r. So derivative of cos is minus sine, so minus sine phi, and then phi dot, as it is not function of t but we are differentiating with respect to t, so phi dot should be there, then plus r dot cos phi. Then let us find y dot. So if you find y dot, then what you will get? If you find y dot, then we will get r cos phi phi dot plus r dot sin phi. We get this. So now as we are going to find a Lagrangian, so we know the Lagrangian equation, the Lagrangian L is given by this, L is equal to T minus V. Okay, T means kinetic energy. So if this is the equation, what gonna be the kinetic energy? Here you see we have three position axes, three coordinates x, y, and z. So that's why the kinetic energy term will be half m, instead of v square there will be x dot. X dot means v, so x dot is square, y dot is square for the three coordinates, z dot is square, isn't it? We get this. Then minus potential term will be half sorry, not half, mg z. Okay, so mg mgz. It will be mgz. Okay, because equation of the motion is given in terms of z equal to this, so here potential will be mgz. So now if you put the values of x dot, y dot and z dot here, and if you put the z, then what you are going to have, then you're going to have half m root over 1 plus a square r square r dot plus r dot square phi dot square minus gar square gar square. So here you see this should not be r dot, this is r only, not r dot, sorry. So how we have got this? Now you see, if you find x dot square and y dot square, what you will get? X dot square will be equal to r square sine square phi and phi dot square minus 2r sine phi dot r dot cos phi, r dot cos phi plus r dot cos square phi. If you find y dot square, then you will get r square cos square phi, then phi dot, then plus 2r cos phi dot, then r dot sine phi dot, then plus r dot square sine, you will get r dot square sine square phi. You get this. Then here you can see these two will be cancelled, these two terms, and these two terms will be cancelled, and from the remaining part you will get that x dot square plus y dot square is equal to r square phi dot square plus r dot square. Okay, if you simplify the remaining parts, here if you see, if you take here so it should be phi dot square. If you take r dot and phi dot square common, then inside the bracket you will get sine square phi by cos square phi, that's gonna be 1. So that's why we have got this. And from here you see, if you take r dot square, that should be r dot square, and here also r dot square. If you take common, then inside the bracket you will get cos square phi by sine square phi, that's why it's become r dot square only. So hope you have got this. Then if you put this x dot square y dot square here, then if you put the z square z dot square that we have got here, this is z dot. If you find a z dot square, if you put here z dot, then again if you put the value of z here, then you will get this, and this is nothing but this is option D. Okay, so let me write it clearly. Half m 1 plus a square r dot r square, then r dot square plus r square theta dot square minus gar square. So one more thing, this m is taken common here. Sorry, not pencil I have taken. So this m is taken common here. So this is your answer. So hope you have understood. Now let's move on to next question. So here you see in this question, this is June 2011 CSIR NET. So Lagrangian of a particle of charge E and mass m is applied in applied electric and magnetic field is given by this. The Lagrangian of this particle is given here, where vector A and this phi are vector and scalar potentials corresponding to the magnetic and electric field. respectively. Which of the following statements is correct? So we need to find a correct statement. So here you see, so as you can see, these two values, vector a and phi, these are vectors and scalar corresponding to electric and magnetic field respectively. Okay, so magnetic and electric field respectively. So here you see, then in EMT you should get this transformation, Gauss transformation. So according to Gauss transformation, this a vector that is a function of r and t, that should be a dash plus grid lambda position vector r and t. So here lambda is some scalar. Okay, so now phi, that's gonna be position vector r and t, that's gonna be phi dash minus del lambda by del t vector r comma t. So here is the Gauss transformation. Now we have the here Lagrangian is given, so that is what Lagrangian is L is equal to half m v square plus e a vector dot b vector minus e phi. So this is the Lagrangian. So this is set of Gauss transformation, and instead of a, if you replace this a by this value and phi by this, then what you will get? Then you will get new Lagrangian L dash, that's gonna be equal to half m v square plus e. Instead of a, we will get a dash plus grid lambda v vector minus e phi dash minus del lambda by del t. So we get this, and if you simplify this, what you will have? You will have half m v square plus e a dash v vector plus e v vector with lambda minus e phi plus e del lambda by del t, del lambda by del t. So here you can see, so what we are going to do in this case, this is our, in this case, if you consider these two and this term, so combining these three terms, we get our old Lagrangian this. So we can write L here, then plus, and you can take E common from these two terms, these two remaining terms, you can take E common, then you will get this. So this is our simplified result. Now here you see, so we have got additional del lambda by del t here. So which statement is correct? So here you see, under Gauss transformation of the potentials, L changes by total time derivative of the function r and t. So that's why, so as it is changing, it is changed by del lambda by del t. So that's why this the fourth statement is satisfied in this case. So that's why it is the correct option is the fourth option. So hope you have understood. Now let's move on to next question. So this is our next question, June 2012 of NET. So here you see, Lagrangian of a particle moving in one dimension is given by this. This is the Lagrangian given. We need to find a Hamiltonian. So now you see, it's very simple. Just what you have to do. So we know in this case that L is t minus v and Hamiltonian H is t plus v. Here you have to assume this t as half mv square, and here you have to consider as p is momentum here, p square by twice m. You have to consider this way. Now if you take this Lagrangian L, then what you will get, L is equal to x dot square by twice x minus vx. So this is the potential term. So kinetic energy is this. So compare with this. If you compare with this, then what you will get, x dot square by twice x is equal to half mv square. Here v square is represented by x dot square, so m x dot square. Then these two will be cancelled. So what will be m? These two cancel. So m is nothing but 1 by x. So here we are going to use 1 by x. Then what will get, 2 to 1 by x. That's going to be equal to x p square by 2. Then this is potential, isn't it? So this will be the Hamiltonian. H is equal to x p square by 2 plus vx. It's very simple. So which one is the correct answer? Correct answer is A, option A. So hope you have understood how to get this answer. So it's very simple. So now let's move on to next. So here is our next question. So this was asked in December 2012 in CSIR NET. So Hamiltonian of a simple pendulum is given. This is the Hamiltonian. We need to find dl by dt, total time derivative of the Lagrangian, where L is Lagrangian. So let me show you. It's very simple, not so hard. So here you see. So our Hamiltonian is given. Let me choose the black. H is equal to p theta square by 2ml square plus mg L 1 minus cos theta. So if you compare with t is equal to, sorry, H is equal to t plus v. So this is the kinetic energy term. Here is the potential, isn't it? So I have told you in the last problem that t should be considered as p square by twice m. So here instead of p we will consider p theta. So this term is given here, p theta square by 2m l square. Then if you simplify this from here, you will get m is equal to twice m l square, isn't it? Sorry, not 2, only m l square. So we know L is t minus v. So I have told you to consider this t as half mv square. So this v is velocity now, minus v of x. Here v of x is this potential. So here you see, so in this case not x, it is theta, isn't it? So that's why half m we have got ml square, so ml square. Instead of v is given, generally we used to write x dot, but here we have the position vector theta, so it will be theta dot. So theta dot square, then minus mg L 1 minus cos theta. This is the Lagrangian we have got, L. So how to find the total derivative? So total time derivative of L, dl by dt, that is given by del L by del p theta into p theta dot minus plus del L by del theta into theta dot, given by this expression. So now what we need to find? We need to find del L by del p theta from here, and we need to find del L by del theta, then p theta dot p theta dot and theta dot. So these two, p theta dot and theta dot, can be obtained from the equation of motion, Hamiltonian equation of motion, those are theta dot is equal to del h by del p theta, and p theta dot was given by minus del h by del theta. So if you differentiate this Hamiltonian with respect to p theta, then you will get 2 p theta by twice m, sorry, not twice, just m l square. Then on the other hand, you will get p theta dot will be equal to minus mg l sine theta, isn't it? So now here you see what will be then dl by dt. So here you see, if you differentiate, if you find dl by dp theta, del l by del p theta, so if you differentiate this Lagrangian with respect to p theta, there is no term consisting p theta, that's why that's going to be 0 into p theta dots, that's going to be 0 again, isn't it? So what we will get, this first term will be 0, so this first term is going to be 0. So from next term, here you see, if you differentiate it with respect to del theta, with respect to theta, then what we will get? So this term, derivative of this term with respect to theta will be 0, because it consists theta dot, not theta. And if you differentiate the second term, what you will get? Minus mgl sine theta. Then with this term, del l by del theta, we have a theta dot into theta dot. If you put the value of theta dot here, so where is theta dot? We have got here, you see, this is theta dot. Theta dot is equal to this one. If you put that here, minus mgl sine theta, and theta dot is 2 p theta by ml square, then you get this relation. And from here, after cancelling this m and this l by l square, then what you will get? So our final answer will be dl by dt is equal to minus 2g p theta by 2g p theta by l and into sine theta. This is our answer. And which option is correct? So that's going to be option A, I think. Here, this is the option, correct option A. So hope you have understood this. Now let's move on to next question. So here is our next question, June 2013 net. So Lagrangian of a particle is given of mass m moving in one dimension, that is the Lagrangian given here, and b is positive constant, where coordinates of the particle xt at time t is given by, so c and c2 are constant. So we need to find a correct option here. So let us use the equation of motion, Lagrangian equation of motion here. So here you see, Lagrangian is given L is equal to half m x dot square minus bx, isn't it? So according to the Lagrangian equation of motion, what we have got, d by dt of del L by del x dot minus del L by del x is equal to 0. Now if you differentiate it with respect to x dot, then what you will get? So then you will get that here you will get mx dot, isn't it? Mx dot. And if you differentiate it with respect to x only, then you will get minus b, so that's going to be equal to 0. So you can make it plus b. So let's write directly plus b. So this is the equation. And here you see, this can be written as m is mass, so m dx dot by dt is equal to, on the other side it will be minus b. So if you divide both sides by m, then it will gonna be minus b by m. So this implies dx is equal to dx dot, not only x, dx dot is equal to minus b by m dt, and if you integrate on both sides, then what you will get, then you will get x dot is equal to minus bt by m plus c. This is one constant. So now again dx dot means dx by dt, so again we need to integrate, so that's why let us keep it c1 here. So then bt by m plus c1. So if you simplify this, then you will get dx is equal to minus bt by m dt plus c1 dt. Now integrating both sides, if you integrate both sides again, then what you will get, then you will get x is equal to minus, here you will get bt square by m, then plus c1t, then plus another constant will be there, that is c2 suppose. Okay, when you differentiate again, you will get ct. So this is x in time at time t. So that's the coordinate. So which option is correct? So here you can see this first option is correct now. So option A is correct. That's very simple. So hope you have understood how to solve this. It's a very simple question. So now let's move on to next. So this is our next question, which was asked in 2013 December. So here you see the Hamiltonian of a relativistic particle of rest mass m and momentum p is given by this. This is the Hamiltonian given. And what is the Hamiltonian here? Let me write the Hamiltonian. H is equal to root over p square plus m square plus bx. So this is the Hamiltonian given. We need to find a corresponding Lagrangian. So here you see Lagrangian of you need to remember this point, Lagrangian of relativistic particle. Relativistic particle is given by L is equal to minus mc square root over 1 minus b square by c square minus bx. So this is you need to remember this result. Okay, you need to remember this result, that is the Lagrangian for relativistic particle. So here you see, so v means in this case v is velocity, that is given by x dot, isn't it? So replace it by x dot. So that's gonna be minus m c square root over 1 minus x dot square by c square minus bx. And one more thing here, it is given in the question that here you can see, let me bring this one, c is equal to 1. So if you put here c is equal to 1, here if you put 1, c is equal to 1, then you will get L is equal to minus mc square root over 1 minus x dot square minus bx. So which option is correct in this case? So this is sorry, one more thing, so this c square should not be there because it is 1, isn't it? So which option is correct? Check the option here. This option B, I think. Yes, option B. So hope you have understood this. Now let's move on to next.